Okay, chapter 2, here we go. Power functions, 2-1A. So splitting this into two sections here in 2-1. It's fun to go through, as always. So starting chapter 2 out, 2-1A, power functions. We're going to graph and analyze some power functions here. Okay, what is a power function? So a power function is going to be any function that's in the form of this, f of x equals ax to the n power. And it's key just to understand here that a and n are non-zero constant real numbers. Okay. They can also be expressed as a monomial function, and that is any function that can be written as this. Oops. As this, f of x equals a, or just like the one we talked about above, f of x equals ax to the n power. All right, so let's talk about some of these power functions, monomial functions. All right, so a couple ones that we know about that we've seen before. So in this case, we're just going to kind of talk about when n, that's your exponent, when that is even or when it's odd. And then what happens with the a value here in these cases. So these first two show you when the exponent n is even, and then we show the difference between when a is positive and a is negative. So over here, you can kind of see that in this one, n is even, a is positive. You've got the upward facing graph, and it's parabola there. And then on this one, you've got kind of a downward facing graph because in this case, n is even, but a is negative here. Okay, a is positive here. But both cases, n are a positive exponent. Okay, so if you look at these, just kind of going through, checking out some of the stuff they have. The domain, that's your x values, right? Those are all real numbers, basically. The range here is 0 to infinity here because it doesn't go below the x-axis. Here, it's negative infinity to 0 because it doesn't go above the x-axis. You got an x-intercept at 0 on both of them. The continuity, it's continuous the whole way through, so continuous for all real numbers. Symmetry, they both have y-axis symmetry. In the first case here, we've got a minimum because it's upward facing. We've got a maximum on the other side because it's downward facing. And we keep going. We can talk about decreasing and increasing behavior as well. There's decreasing here from negative infinity to 0, and then increasing from 0 to infinity. Just the opposite here. We're decreasing from 0 to infinity here. We're increasing from negative infinity to 0 there. And then your end behavior, your limits, as f of x approaches negative infinity, we're at infinity. And really the same thing when x approaches infinity, we're also at infinity because we're going positive on the y-axis. And behavior here, both of them are going to be negative infinity because we're going down on the y-axis, getting further and further down for the y's. Okay, so now let's look at the difference here when n is odd. So, okay, again, just pointing it out, n was even in these situations, and so that's what happened. A is positive, a is negative. Now, what about when n is odd? So your exponent's odd. So we've kind of talked about this in class a little bit the other day about what happens to the graphs here. So n is going to be odd, and a is positive, a is negative. So you can see the difference just in the graph with the curve of the graph here versus the graph here. Okay, look at the curve, how it changes, and how it flips over the origin, and also symmetric. Looks like it kind of flips over the y-axis there, but symmetric with the origin for sure here. And that's what we talked about, right? Remember we talked about even and odd functions? Well, there you go. There's an indicator there. Okay, domain and range for both of these is all reals, negative infinity, positive infinity. You still have an x and y intercept at 0 for both of them. So those are still there. Continuity is continuous basically through the whole thing. There's no breaks on it. So continuous on negative infinity to infinity, or like I said, all reals, like it says here, just different stuff there. Symmetry is the origin, right? We talked about that being odd. Extrema here, there's no maximum or minimum, right? On both of them. So we don't have to worry about that. And then increasing This graph here is always increasing from negative infinity to infinity. It's moving from left to right on the x values. It's always increasing. And this one is always decreasing because that graph is flipped over. Limits are slightly different as well. They're kind of in reverse as x approaches, and the end behavior, as x approaches negative infinity, f of x is going towards negative infinity down here. And then the other side, as x approaches infinity, f of x is going towards infinity that way. Just the opposite on this one, as you can see, negative infinity, as we're approaching negative infinity, we're getting larger on our y's here. As we're approaching negative infinity on x, we're getting smaller with our y's. So that's why that's changed. Okay, so let's practice some of our own. Okay, so we want to graph and analyze this. We can use a graphing calculator and do that. And we can graph and analyze these points here. Okay, so let's look at this one, the first one, 3x to the 6th power. So if we graph this one, you can graph it in your calculator. It's going to end up, I'm just going to sketch it. You can graph it a little better, but it's going to kind of be a little flatter down here and then go up like crazy here. It's like a little bit flatter of a parabola and then goes up like that when you graph it and a graphing calculator. Or you could plot points, obviously. So let's talk now about what our information is. They don't want everything we got on those other ones, but they want domain, range, intercepts, end behavior, continuity, and whether it's increasing or decreasing. All right, so on this one, we can say the domain is going to be negative infinity to positive infinity. The same thing with the range. Okay, the range is going to be the same thing. Or sorry, the range is not going to be the same thing. The range includes 0 and then goes to infinity because there's no negative values, nothing below the x-axis there. So we include 0 with the bracket, and then infinity, we got the parenthesis there. So it's our range. Intercept, we know it has an intercept at 0. Okay, and then our end behavior, let's talk about end behavior. So we're going to go limit f of x as x approaches negative infinity. So what's happening is x is further and further to the left. It equals infinity. And on the other side, the limit of f of x as x approaches infinity, positive infinity on the right-hand side, also goes up. So it would also be infinity there, right? Continuing on, continuity and whether it's increasing or decreasing. Here, continuity, it's going to be continuous. I'll just write it out, I guess. Continuous for all reals. And then finally, our increase and decreasing, we're going to say it's decreasing on the interval negative infinity to 0. Right, this little piece right through here is decreasing as we go from left to right. It's working downward, and then we're going to go back up. So it's increasing on the interval 0 to infinity. Okay, so just looking at those things, I know there's a lot to it. So I'm actually going to skip number 2. We can look at this in class, and we can go over the graph and do all this as well, just to make sure we're doing it. So you can do that one on your own, and we'll take a look at it, okay? Or we can do it in class, whatever. All right, next up, reciprocal functions. I'm just trying to save time on that video. All right, reciprocal functions. If we go here, we can say that functions are in the form of 1 over x. So you're looking at your fractions here. Looking at fractions, 1 over x, which equals x to the negative 1 power. Remember that we have those negative exponents. So we're kind of talking about negative exponents and fractions here. And we definitely have to make sure we know that x is undefined at 0 in these cases because you can't have 0 in the denominator. Therefore, power functions are defined when n is less than 0 and will contain discontinuities, I should say, right? Discontinuities. So in reciprocal functions, we're talking about negative exponents basically, and there's going to be some places where we're not continuous, not defined. All right, so number 2, kind of work through this one together, and we'll just kind of look at some things here as we go. So if we look at the first one here, f of x equals 3x to the negative 2 power. We can see we have a table of values here, And that gives us, like we said, we're going to have a discontinuity here because we're undefined at 0. And you can see all the information they give you, the domain. Notice the domain, right? We've got, because it's discontinuity at 0, because it's undefined there, we have a union in our domain. It's almost all reals. It's just not at 0. So negative infinity to 0, along with 0 to infinity. The range is just positive numbers, as you can see by the graph over here. It's just positive numbers, so 0 to infinity. It does not have an intercept. It doesn't cross any axis there. And then the limits, you can see there. Instead, just notice the difference for the limits. Instead of approaching infinity or negative infinity, as f of x gets, as x approaches infinity, as we get smaller and smaller out here, we're actually, as we get smaller and smaller this way, we're getting closer and closer to 0 on y. Okay, and same thing over here. As we get closer and closer this way, we are getting closer to 0. Continuity, we have an infinite discontinuity at x equals 0. Remember, infinite discontinuity is these ones where they shoot way up and go crazy up here, and that is where we have infinite discontinuity. It's never going to touch 0 there. And then we're increasing and decreasing, as you can see, from negative infinity to 0, decreasing from 0 to infinity. So let's practice one of those as well. So graph and analyze this one, 4x. Where did that go? Hold on a second. There, I found it. All right, so let's graph and analyze this one. Same idea. We're going to graph this thing and look at it. So the graph of this is actually going to be a little bit wild. As you're going to see, it's going to go from, it's going to kind of look like this. As you sketch it. And then this one here is going to start up here. And okay. Again, it's a reciprocal function. We've got a negative exponent that we're dealing with. Okay. So let's look at just start looking at the graph. Let's start to go through our things here. Okay. The domain is going to be negative infinity to 0, right? Because it's not including 0 in the middle there. And then we have a union, right? That we talked about 0 to infinity here, okay? The range is going to be similar because we just don't have anything at 0. So it's going to be very similar, negative infinity to 0, and then union with 0 to infinity. So we do have positive and negative numbers there. We don't have any intercepts, no intercepts, because it doesn't cross any axes. And then when we talk about our limits, we can say, switch over to blue here, make it a little easier that way. The limit of f of x as x approaches negative infinity is equal to 0, right? As we get closer and closer to the left, we get closer and closer to 0 on our y values. And then same thing on the other side, the limit of f of x as x approaches infinity is going to be also 0. Okay, we have a couple more things to look at. Discontinuity. Again, we've got infinite discontinuity. Infinite discontinuity. At x equals 0. And then we are increasing and decreasing. This one is decreasing from negative infinity to 0 and increasing from 0 to infinity. Here you can see that. Oh, sorry. I'm sorry. I messed that one up. It's not increasing. We should just put and. Erase that, sorry. So 0 and also from 0 to infinity. So let me just take a moment on that one. We're decreasing, right? If we're going from left to right here, we're kind of going down this way. And then we start back up here and we go down again. So it's decreasing on both of those. You just can't include 0 there because it's undefined at 0. All right. Trying to cruise here. I know, it's a lot of stuff here. let's talk about the nth root. Where are we at time-wise? Okay, we're doing okay. All right, so rational exponents. So here we're gonna graph this sort of thing, and I'm gonna let you kind of pause and write whatever you need to down here. But this is saying that, you know, when you have a fraction as your exponent, and we've got the denominator and our exponent. Remember, we write this as the nth root of x. Okay. So, for example, if you have p over n, and p over n is already simplified, it's a fraction in its simplest form. Okay, make sure it's in its simplest form, which means we reduce as much as we can. That means the nth root of xt. Okay, so x to the p power, and then we take the root of the denominator. Okay, and then just remember that if n is an even integer, then we've got to be restricted to non-negative values. It's going to have to be 0 or positive if you have an even integer here, because we'll be squaring it, right? So, or square rooting it. All right. So let's take a look at this one, and you can see the table here, and we can see how it works. All right, so we take a look at this one. You've got f of x equals x to the 5 over 2, x to the 5 over 2. So what that's saying basically is the square root of x to the 5th power. Okay, it's the nth root here, the square root of x to the 5th power. Whoa, can't write it that way. Or that way. Square root of x to the 5th power, basically. Okay, that's kind of what we're saying here. So punching it in the calculator, you're going to get this stuff if you did a table of values. And now you can kind of go ahead and look at this stuff. The graph is right here to the right. As we keep going here, you can see your domain, obviously just positive numbers. So 0, we don't go anywhere left of the y-axis. Your range is the same because we don't go below the x-axis. It's just everything positive for x, everything positive for y. So that's why your domain and range are 0 to infinity. X and y intercepts, we have one at 0 right here, good. And behavior, really there's only one limit because we don't have a x approaching negative infinity here. I guess, you know, x approaches 0, but then it stops. So we really have to put one end behavior where this graph ends and starts at that 0. So the limit of f of x as x approaches infinity is infinity because we keep going up towards infinity. It's continuous the whole way from on the graph, from this whole way in the domain from 0 to infinity. That's the only domain we have to look at. And it's increasing the whole way as well. Okay. So let's look at another example of that, and then you can put those answers in, pause, rewind, do what you need to do. Same thing here. We've got 6x to the negative 2/3 power, right? So this is saying the cubed root. Basically, this is saying the cubed root of 6x to the negative 2 power, or, you know, 1 over the cubed root of 6x squared. Right? That's kind of what they're saying here. So doesn't matter when you punch it in a calculator, you can still do that. Here's your table. You get these values. You can see, again, it's undefined at 0 here. So when we have our domain, the graph is over here. You can see, again, when your domain, now we've got to use a union because we do have negative values for x, and then we do have positive values for x. We just don't have 0, so we have a union. Your range is still just positive numbers, still 0 to infinity. I know it looks like it's going to curve off this way, but it might get lower and lower and lower, but it is not going to go below the x-axis. Why? Because of what we said on the last page about if we have a even number there in one of the exponents. Anyways, intercepts, there's no intercept, doesn't cross. Your end behavior is here. Now we are approaching negative infinity, and f of x equals 0. As we approach infinity, f of x equals 0 as well. They're just going to keep getting closer and closer to 0. And again, you can see that with your limit here, that it's undefined. So we have an infinite discontinuity at x equals 0, and we're increasing and decreasing at those intervals there. All right, so the last one. Let's just go ahead and look at this. We'll do this one together and see how it looks. All right, the graph of this, we'll sketch it really quick. It's going to kind of look something like this. If we go 2x to the 3/4 power, So it's going to kind of go, like I'm putting like units of 2, 4, 6, 8 just to give some room here. So I'm going to go in units of 2, 4, 6, 8, and 10 up here. And, you know, when I sketch the graph, it looks really close to, let's see, it seems like gets up close to 4, not quite. And then kind of goes up in this route here, something like that. You know, you could also, you could do a table of values to get points here if you wanted to. And remember, because we have, just to point that out again, because I mentioned it on the last one. That right here, if you've got an even number for n, if n is even, then it's going to be restricted to non-negative values. Okay, so again, that's why on this graph, you can see we know it's not going to go below the y-axis. Even though it's going a little closer this way, it might keep going and going closer to 0, but it's never going to cross there. Okay, so same thing here. We have an even value for our n value. So that means when I plug in values, if I wanted to plug in values, I'm really only going to use positive numbers and 0. I can't use any non-negative, or I can't use any negative numbers. And like if you wanted to, 0 would be 0, 1 would be 2. I think this is 3.36, 4.55. We've got 5.66 here, and it kind of goes on and on. If you wanted to plot the points, just to get a better idea of the graph. Not saying you have to. Okay, but sometimes it helps to see where are these, how do I get these graphs? I don't have the graphing calculator. Well, I can plot the points. It's kind of nasty. All right. Domain. Okay, again, we include 0 here, and then it's all positive numbers, so it's 0 to infinity. Your range is also going to be the same because we don't go below the y-axis, so it's 0 to infinity. Brackets, though, right? Brackets, because we do include 0. We have an intercept at 0. Okay. A limit, again, I'm restricted to just positive numbers. So I really don't have to talk about x being equal, x approaching negative infinity. So as x approaches infinity, what's the limit of f of x? It's equal to infinity. It's going to keep going on in this direction here. And then finally, we are continuous. On this interval, again, the bracket for the 0 is included there, 0 to infinity, and then we're increasing the whole way on that same interval from 0 to infinity. Whew, okay, lots to that one. Again, we'll discuss the one. Oh, I was hoping to keep it under 20. I went a little bit over, but that's all we can do. I will say goodbye, and we'll talk tomorrow.